Ontology is a multifaceted concept with significant implications in both philosophy and information science. Let's delve deeper into its different aspects.
1. Philosophical ontology. Philosophical ontology is a branch of metaphysics that deals with the nature of being and existence. It seeks to answer fundamental questions about what entities exist, their essential properties, and how they can be categorized and related. Existence. Philosophical ontology investigates what it means for something to exist. This includes exploring different modes of existence, e.g., physical, abstract, and what criteria must be met for entities to be considered existent. Categories of being. Ontology categorizes entities into different kinds, such as substances, properties, events, processes, and relations. This categorization helps in understanding the basic structure of reality. Ontological commitment. Philosophers discuss what kinds of entities a particular theory or worldview commits to existing. For example, a physicalist ontology commits to the existence of physical objects, but not to abstract entities like numbers. Information science ontology. In information science, ontology refers to a formal representation of a set of concepts within a domain and the relationships between those concepts. It is used to model domain knowledge, enabling effective data sharing, interoperability, and communication between systems. Conceptualization. An ontology in information science starts with the conceptualization of a domain, identifying key concepts, their properties, and interrelationships. This conceptualization is then formalized using a specific ontology language, e.g. OWL, Web Ontology Language. Components of ontologies. Classes, or concepts. These represent sets of entities within the domain. For example, in a medical ontology, classes could include patient, doctor, and disease. Individuals, or instances. These are the actual entities within the classes. For example, John Doe might be an individual instance of the class patient. Attributes, or properties. These describe characteristics of the classes and individuals. For example, a patient might have properties like has age or has medical history. Relationships. These define how entities are related to one another. For example, a doctor may have a relationship treats with a patient. Hierarchical structure. Ontologies often have a hierarchical structure where classes are arranged in a taxonomy. This hierarchy can be represented as a tree with more general concepts at the top and more specific ones below. For example, mammal might be a subclass of animal, and dog might be a subclass of mammal. Reasoning and inference. Ontologies enable reasoning about the entities within a domain. By defining rules and relationships, it is possible to infer new knowledge from existing data. For instance, if a dog is a mammal and all mammals are animals, one can infer that a dog is also an animal. 3. Applications of ontology. Ontologies are used in various fields to structure and organize knowledge, improve data interoperability, and support decision-making processes. Knowledge management. Ontologies help in organizing and retrieving information efficiently within organizations. They enable the integration of diverse data sources and facilitate knowledge discovery. Semantic web. The semantic web relies on ontologies to make web content machine-readable and interoperable. Ontologies provide a common framework for data exchange, enabling more intelligent web services. Artificial intelligence. In AI, ontologies are used to model knowledge about the world, allowing systems to understand and reason about complex domains. They are crucial for natural language processing, expert systems, and robotics. Healthcare. Medical ontologies like the SNOMED CT or the gene ontology standardize terminology across healthcare systems, improving patient care, clinical research, and interoperability. Business process modeling. Ontologies help in modeling and optimizing business processes by providing a clear structure of activities, roles, and resources. 4. Challenges and future directions. Scalability. Building and maintaining large-scale ontologies is challenging. Ensuring they remain accurate and up-to-date requires significant effort. Interoperability. Combining ontologies from different domains or organizations can be complex due to varying standards and conceptualizations. Dynamic environments. Ontologies need to adapt to changes in knowledge and context. Developing methods for dynamic and flexible ontologies is an ongoing area of research. Usability. Ensuring that ontologies are user-friendly and accessible to non-experts is crucial for their widespread adoption.
In conclusion, ontology, whether in philosophy or information science, is a powerful tool for understanding, categorizing, and organizing entities and their relationships. It provides a structured framework that supports knowledge representation, data integration, and advanced reasoning, with applications spanning numerous fields.